Hello, Stardust Explorers. Welcome back to Stardust Discovery with the Astro Princess. Today, we'll be continuing with solving some of the WASSCE past questions. We started off with 2021 exam past questions, and we'll be continuing today. And the topic for today is satellite motion. So we'll be learning how to solve satellite motion equations. So we have this question in the theory part 1 section. I'll read it. The first question says, name two artificial satellites. Name two artificial satellites. First of all, what is a satellite? So we need to remind ourselves that satellites are objects that revolve around another object. Now we have two major types, natural satellites and artificial satellites. And natural satellites are those objects that are natural, they are celestial objects themselves, and they are revolving another celestial object. The one that's asked here actually is artificial satellite. So artificial satellites are man-made satellites. They are actually made and placed in orbit of another celestial object to gather information. Now you are asked to list two of such types of satellite. So you have the list of them everywhere. We have the recently launched James Webb Telescope. You have the Hubble Space Telescope. There is the International Space Station. A lot of telecommunication companies have satellites in space, SpaceX, and a lot of these are also from different countries. So if you are from Nigeria, for example, there is the Nikon Sat-1, there is Nikon Sat-2. I'm sure other countries also have their own communication satellites in space. Now, let's get to the second question. A geostationary satellite moves in an orbit of radius 6,300 kilometers. Calculate the speed with which it moves in the orbit. And you're given the value of pi. Now, in order to understand this question, we should first of all understand what is a geostationary satellite. Okay, let's take some step back. There are different orbits for satellites, and the different types of orbits determines, different types of satellites. Now, one of those type of orbit is called geostationary orbit. So any satellite you place in such orbit will be called a geostationary satellite. Now, in this case, we are given this scenario of a geostationary satellite. Now, the orbital period and the orbital radius of a geostationary satellite are related in such a way that they ensure that the satellite is synchronized with the Earth's rotation. What that means is that a geostationary satellite orbits the Earth once every 24 hours. This 24 hours is the same as the period of rotation of the Earth. Now that means that the orbital period of a geostationary satellite is the same as the orbital period of the Earth, which is 24 hours. Now, given the orbital period and the radius, let's call that r, you can actually calculate the orbital speed, which is what we are asked to calculate here. Now, the equation for that is given as v equal to 2 pi r over the period t. Now, I must mention that in order to understand this vastly, there are additional material you need to read, and I will give you the link in the description box. So make sure you go through to understand more what all of this means, especially the geostationary satellite. Because if you understand what that means, then you agree with me that you have been given the orbital period for solving this equation, even though it's not written physically. Now we have established from the last slide that value is 24 hours. Now you remember I mentioned of converting all your parameters to SI unit. Hours is not the SI unit of time. Second is. So we have to convert that period from hours to seconds. We do that by multiplying it by 3,600 seconds, and that gives us 86,400 seconds. The radius of the orbit given is also not an SI unit. Kilometers needs to be converted to meters, and you can do that by multiplying the value by 10 to the power 3. Now, when you've done all of this, you can now substitute these values into that equation, and that gives you 458 meters per second. So this is the orbital speed of that satellite. Remember, your formula is 1 full mark. Your accurate substitution of the parameters into the formula in their right units gives you another full mark. Your correct answer with the right SI unit will give you another full mark. Failure to have any of these will make you lose some marks. Okay, I hope this was helpful. I hope it's clear. Ask me your question in the comment section. Let me know what you think about this, and like this video if you think this was helpful. Share this video as well to people who need it. Subscribe to our channel, and I will see you in our next one. Don't forget, your worth is not determined by the world standard, but by the love God has for you. Thank you, and bye for now.